Emily, have we started recording? Yes, thank you. So, yes, so let me start the day today with energy trade, the routes, what are the various routes on which energy is traded, and what are the geopolitics of energy, and especially in the context of climate change. And we recently summarized the COP26. It makes sense that we review the entire process, the whole business of energy. So let me quickly share my screen with you. Okay, Emily, can you give me the screen sharing right?
Yes, ma'am. Ma'am, you can share now.
Yes, I could see that. Thank you, Emily. So is my screen visible to everyone? Is my screen visible, Emily?
Yes, ma'am, it's visible.
Okay, thank you. So yes, this is the topic of my talk today. I'll be talking about the global energy scenarios in context of the entire landscape, how it is distributed, briefly touch the problem of energy access as well. The whole world is talking about it. What are the trade, how the trades are done, what are the route through which these trades are materialized, and the geopolitics of energy. I mean, as you understand, with recently concluded COP26, we understand how the politics of energy actually works. So very quickly, if we look at the worldwide consumption, and here you see the word, there is a primary energy consumption which is reported, and I explained it to you yesterday, why we report everything in primary energy, why don't we talk in terms of secondary energy. So as you can see here we have described it as primary energy consumption globally in 2020, just very last year. Though there was a little decline, little bit of dip in last year's energy consumption, primarily because of the worldwide lockdown that we all witnessed, but the trend were more or less same. So as you can see here, the biggest energy consumer in the world was China, followed by US and followed by India. And India had been taking this position consistently for last couple of years. There have, as you can see here, there has always been a competition here. First and second position, there is a very clear winner in terms of the number one position for energy consumption globally. It's order of magnitude higher, followed by US. Third and fourth, it is either India or China. But if I'm not wrong, for last 3 or 4 years, it's India which is at the third position in terms of the total energy consumption that the country is having. So Russia, Japan, Canada, as you can see, so on and so forth. So altogether, this is the broader picture of energy consumption globally. Again, if we break it down in terms of, as you can see here, tons of oil equivalent, we discussed the tons of oil equivalent as well. Various energy sources, overall energy, not just in terms of electricity, we are talking about electrical, transport vehicles, I mean, gas, oil, all such thing, everything included in every form. I mean, if you look at countries, not every country is using the clean fuel, including firewood and everything, the net amount, the total amount of energy that has been used by these various countries. This is a political map, as you can see here. And in terms of oil equivalents, if we convert all the forms of fuel into oil, then what is the equivalent? What is the equal amount of oil based on that? And we discussed this yesterday. And the same figure, as you can, the same data basically represented in a more pictorial form. So this is how the energy consumption over the globe looks like, right? As you can see, below 50, the more darker you are, more is your energy consumption, basically. This is just to set the tone of the presentation today. Now, look at it. We talk about climate change, and whenever we talk about climate change, it is inevitable that we don't talk about energy. And if we look at the very onset, yesterday we talked about from industrial revolution to digital revolution, right? So if you see at the onset of the industrial revolution, at the very onset of the 18th century, our energy consumptions were very limited, very little. This is in terawatt-hour given here. It was very limited. It's only at the beginning of the 19th to the 20th century that we started to consume a good amount of energy. And as you can see here, there is a phenomenal growth after 1950. 1950, it's important, and this is the time when many industries grew. Power sector grew phenomenally. Fertilizer industry also grew at that point of time. So all sorts of industries were picking up, and there was this combined impact of all the industries that was happening over the climate. Not just the power industry, but every other industry which was deriving the power from the power industry, was deriving the electricity or their energy from this power industry. So it was not just electricity as electric per se as we use in our homes and our offices, but even the industry. And these industries were used in various sectors: road, transportation, agriculture, and all the allied industry that are there to support them. So as a result, our energy demand really grew. The way aviation industry took up, the way transportation was kind of revolutionized. So all that resulted an increase in our demand for energy. So as you can see here, over the last couple of centuries, or even before that, if you could track it before that, it was very much parallel to this line only. It's only after that that you can see here, there is this tremendous increase in our energy demand. Traditionally, if you look at the onset of the 20th century, we were using biomass and we were using some amount of coal. Primarily, we were using only biomass, that is solid fuel, and there was coal. But as we progressed further, and because of all the research and development and new forms of coal fuel being discovered, oil exploration happening, you see here that somewhere in the middle of the 19th century, and I showed you some of the data about oil yesterday as well, oil came into existence. As you can see here, there was oil which is picking up. It came only in the middle of the 19th century, the 20th century, and then it grew. And look at the way it grew, the area which is under this graph. And today, if you look at it, look at the share of oil. So mid of the 20th century, it was almost zero. At the onset, it was zero. And then today, it is as broad as that of coal. And then sometime along the line, gas came into existence, and gas is equally has a broader share here. Nuclear and other sorts of renewable energies are also picking up fast. And nobody was talking about renewable till, if you look at it, somewhere around 1970s, early 70s, if you look at it, right? And it all started with some of the environmental movement that took place, some of the conferences that happened at certain point of time in early 1960s and 65, 68. There was a very famous book that came up by Rachel Carson by the name of The Silent Spring. And that kind of triggered the debate globally that what are we doing to our world? And that was primarily about the chemical usage of the fertilizer industry and its impact on the nature. So in my opinion, that probably was the first trigger. From there we started, or the world started talking about the environmental impact of the various services and goods that we were deriving from energy. Right. So this is very briefly how our energy demand or our sources of energy moved from being purely biomass to biomass, coal, oil, gas, then sometime nuclear, and then now we are talking about renewable. What is good here, if you could just move to the next slide here. If you look at it here, right, the earlier slide was from 1800. Now we're talking about 1965. As I told you, it's only in the 1965 that the things started to change a bit, right? So you can see here we have oil, then we have coal. In fact, oil started, the reason why you are seeing oil at the bottom is because the share of oil now is more than that of coal. So oil, there is coal, there is gas. Sometimes we talk about nuclear, but nuclear has been a very constant increase in nuclear. Then we have the hydropower. It was there in the 60s as well, but only picked up a little later, followed by very minimal share of renewable, as you can see here. So if you focus at 2019, still we see that a major share of the world energy demand is met through fossil. It's met through coal, oil, and gas. A bit from nuclear, and a little more than nuclear is coming from our hydropower, and then there are renewables here. So we have a long way to go when we're talking about um, net carbon, net zero emissions, or when we're talking about going completely green. You can see here, if this is our demand, I mean, even if we talk about 2019 demand, and the global demand in totality is actually increasing. But even if we peg it here at this particular number, let's look at this particular number only. The role that renewable, let's take hydros also into renewable, it's only this much, vis-a-vis this demand, which is actually met through fossil. So there is a lot to do. There's a long way to go before we really say that we are on the right trajectory of 2 degrees Celsius or 1.5 degrees Celsius of global warming. There's a long way to go. That's the take-home message. And also, we are talking about the geopolitics of energy. And I don't think any other time would have been better than this to discuss about it. We just concluded COP26, and we saw what kinds of results that are coming out from that conference, what kinds of debate that, we are a week over that, and you open any newspaper and we hear about, or we read about what went right, what went wrong, what were the issues, what were the undercurrent discussions, what was the undercurrent tension during the COP26 meet. But if you look at, energy is very, very sensitive to price spike. Europe is one such, geological locations, if you'll say so, which is very vulnerable in terms of to meet its energy demand. Right. And similarly, coal, despite being one of the major, if I'm not wrong, third in terms of our global coal reserve, we still have coal shortage. We very often, the threat is there. Multiple reasons. Environmental litigations could be other, despite being a huge amount of reserve that is there with the country, mining of that would be an issue, so on and so forth. Right. So energy is very sensitive to multiple things. Therefore, the question is, are we seeing a global energy crisis? So to make it more clear, I would like to share a very recent video with you. So let me just quickly get back to it. Let me share the screen and sound.
When Europeans turn on their radiators or hit the light switch, they expect reliable and affordable energy to bring them heat and light. That confidence is flickering as energy prices soar. Faced with calls for a bold response, the European Union says it will examine the way its power market is run and will consider calls to revamp regulations. However, the EU insists its plans to tackle climate change must stay on track. Winter is coming. Fears of the impending temperature drop in the Northern Hemisphere have driven gas prices to record highs. Since the start of the year, prices have surged a chilling 670%. Spaniards are struggling to pay utility bills, and Madrid wants the EU to make group purchases of gas, much as it did for vaccinations for COVID. Greece wants an EU fund to help governments weather the crisis. However, other countries, led by Germany and the Netherlands, urge caution. They argue the energy crunch is short-term and related to the unprecedented supply shock following the coronavirus pandemic. Some members fear the energy crisis could lead to social unrest and should take priority over combating climate change. But the EU's climate chief, Frans Timmermans, says there's no alternative.
The levels of social unrest, if we leave the climate crisis untackled, are going to be unsupportable. Our children will wage wars over water and food if we don't tackle the climate crisis. And of course, tackling the climate crisis also leads to a number of difficult decisions, a number of big changes, but let's keep our eye on the ball. The problem here is a climate crisis, and we need to act quickly, and Europe needs to lead so that the rest of the world understands where we need to go.
Next week, the European Commission will propose measures aimed at easing the price surge for consumers and making sure Europe's kettles don't go off the boil.
And for more on this, I'm joined by Leon Izbicki. He's a natural gas analyst with Energy Aspects. Leon, thank you for coming on to the show. I want to start with what happened yesterday when we saw prices explode, wholesale gas prices explode. What exactly happened?
Well, I think, that's a good question. Ultimately, the market has become untethered because we have blown through the traditional caps, so to speak, on gas prices, which are usually the gas to coal switch. And after that, we have also blown through the gas to liquid switch. So ultimately, the market was trying to find a level at which there was further price resistance, in this case, probably also from shedding industrial demand for natural gas. But I think also it's important to highlight that ultimately there is also a large amount of speculation in the market, and this speculatory bubble really was set to burst yesterday.
Remind us, why are some countries more exposed to these spot market rates than others?
So ultimately, this is a question of the amount of stocks that you have in a country, and also fundamentally, really, how much you could actually fill up those stocks over the last summer. So the countries that we're seeing, particularly in Northwest Europe, having historically very low stocks, such as, for example, Germany and Austria, are essentially going to drive up that price in the TTF in order to further free up natural gas demand in order to bring that into storage.
Member states are looking at block purchases as a solution. Some of them are, we should say. Is that a reasonable solution, that the EU does something with gas, sort of like what it did with vaccines, this idea of a purchase for everyone?
I think it certainly is, but I mean, the fundamental question is what European policymakers can really do in the current situation, and fundamentally also where they are going to purchase that gas from, because Asia is showing no signs of essentially losing the price war with Europe that is bidding for LNG cargoes. And simultaneously, there is also this underlying question of whether Russia can actually increase flows to Europe. So while it is a good thing to think about fundamentally purchasing gas en bloc, the question is, where is that gas coming from?
There's been a lot of criticism that Russia hasn't delivered as much as it needs to in a crisis. How do you see it? Have you been able to look and see what they have been delivering?
Do you want to accept payments on your website? What if we told you that you can
Well, so fundamentally, I think it's important to highlight that ultimately on a year-on-year level, Russian flows to Europe have increased, but they are still below, around 18% below pre-pandemic levels. And this happens in the context of where we're actually seeing gas demand in Europe grow overall around 3% compared to pre-pandemic levels. So Russia has been meeting nominations on the European gas market. But I mean, fundamentally also, the initial problem is that Russian production has increased, but a lot of that production actually flows into the Russian balance itself as the country is looking to fill up its low storage.
All right. Leon Izbicki with Energy Aspects. Thank you very much.
Thank you.
All right, DW correspondent in Brussels, Marina Strauss, joins me for more. Marina, good morning. So we hear that the EU is encouraging member states to provide relief to their citizens to try and offset some of these rising prices. But is Brussels itself prepared to do anything?
Well, in this case, it's urging its member states, its 20 member states, to help small businesses and consumers, because these short-term measures is something the single member states have to do themselves. But in the longer term, on EU scale, we saw that in the report, some EU member states, for example, France and Spain, are asking for a change of the rules that are governing the EU's energy market. For example, Spain suggested this strategic gas reserve for the whole of the EU for emergencies. And Wednesday next week, the EU Commission will present a toolbox of medium and long-term measures. So we have to wait a bit and see what kind of ideas they come up with. But this clearly shows there is a political will to tackle this issue here in Brussels.
Now, Marina, we also heard yesterday that Hungarian leader Viktor Orban made a connection between rising prices, energy prices, and the rising cost of carbon emissions in the EU. The EU, of course, covered by that emissions trading scheme. Now, those prices have risen somewhat, though not as dramatically. What do EU leaders say to that kind of connection that he's putting there?
I talked to Franz Timmermans, the commissioner or the vice president of the EU Commission who's responsible for climate, we saw in the report. And he told me yesterday that according to the Commission, this is not correct. So he said that those measures are only responsible to a very small extent, a maximum of 1/5, he said. And he claims that putting a price on CO2 emissions is not the problem, but the fact that the market demands are on an all-time high due to EU economies coming out of the COVID-19 crisis. And as other EU politicians, he says that the quicker the EU switches to renewable energy sources, the quicker EU citizens are protected from these energy spikes we saw in the last couple of weeks.
All right, Marina Strauss, DW correspondent in Brussels. Thank you very much. As we mentioned earlier, European countries are certainly not alone in their struggles with energy supply. India is facing a crunch in coal, following a surge there in demand. Now, energy suppliers have recently added over 28 million consumers in India, mostly lower and middle class and poor, who are buying goods like fans, lights, TV sets. Now, it's not just soaring demand. Recent monsoon rains flooded mines and disrupted transport, and that helped send coal prices up sharply for power stations. Now, coal generates nearly 70% of India's electricity, 3/4 of which is mined domestically. A state-run giant Coal India produces most of the country's supply and says that it's now on a war footing to ensure deliveries. But supplies for more than half of coal-fired plants are at a critical level. Delhi says that it's even considering rebooting idled power stations. Now, for more on this, I'm joined by DW correspondent Charu Kartikai in Studio Delhi. Charu, good to see you. How serious could this situation get for businesses and families in India?
Good morning, Stephen. It's an anxious morning for officials of the Power Ministry in India because the situation appears to be very critical as of now. There are 135 coal-powered power plants that the regulatory body monitors, and out of these, at least 16 have 0 days of stock, which means they have completely run out of stock. On an average, these plants have been left with about 4 days of stock. So that's a pretty critical situation. At this point of time, businesses are definitely scared. For households, it's not really, they do not really appear a bit perturbed because India, these kind of blackouts, it's a very rare phenomenon. Last time India had a blackout, it was in 2012. It was pretty scary though, because about 400 million people were affected on day 1 and another 600 million on day 2. But that was 9 years ago. And of course, memories are still very alive of that blackout. But at this point of time, it is being ruled out that we are heading towards that kind of a situation again.
Charu, how is the Indian press looking at this, for example? Is this an issue? Do they see an issue here about energy diversification in India? Did they see it about green policies? Did they see this relating to the pandemic? How's it being handled there?
It's all these things combined, Stephen. One is, of course, the pandemic had led to a fall in demand, so probably the authorities had gotten a bit lackadaisical about how to manage the supply, because post-pandemic, there's been a surge in demand, even though industrial activity is yet to pick up. So this is mostly household demand. As you rightly mentioned in the introduction, that 28 million households have got new connections. So the consumption has definitely gone up. But of course, yes, this is a problem with India's energy mix. As you rightly said, some estimates suggest that coal accounts for about 70% of India's energy mix. We've been trying to go ahead with solar and increase our dependence on solar, but that hasn't been working out very well. There are some estimates suggest that this month, the growth in solar output has fallen by about 40% as compared to on a year-on-year basis. So solar is not really achieving its potential, and which is further increasing our dependence on coal.
All right, by many accounts, a bad year for renewables. Charukartikai in Delhi, thank you very much.
Right. So that was about the global energy crisis. Just to give you a very brief about two continents, we talk about India as a country and EU as a continent, like what kind of crisis they were facing just a month back. Yeah, I mean, of course, there is a solution that has to be designed, and they came up with very innovative solution for it. But the idea to show this video to you was to just to give you some idea, some detailing about the role that energy plays in our day-to-day life. Yes. Now, let's quickly have a look at it in terms of what is our CO2 emission per capita. That means CO2 emission per capita, including all, this is based on our GDP. As you can see here, GDP basically means that all services, all goods, everything that the country has done, based on that, what is the emission that they are doing? Because as you understand, we are studying it from carbon neutrality point of view. And you see that, of course, it's very obvious that as the GDP increases, majority of the country, certain exceptions are there that despite being not so high on GDP, their emissions are higher. But on an average, you would see that as the GDP of any country is increasing, as it is generating more and more revenue, let me put it this way, their annual emission or consumption of CO2, emission of CO2 probably we all can understand or correlate to, also increases. Right? So as a country becoming more and more developed, more and more GDP, it is producing more goods and services in-house, they are emitting more CO2. As you can see here, there's Malawi, Ethiopia, Benin, Bangladesh, Bolivia sitting here, and then Latvia, Russia, Israel, Austria, Australia, Saudi Arabia, Brunei, and Qatar sitting here. So as you become more and more developed, you emit more. And the divide, I mean, there's a lot of information written in here. It is also given continent-wise, like in African nations, what is the kind of emissions that we are seeing? Of course, what is the kind of GDP that we are looking at? Asia, it's very mixed, it's spread across the GDP depending upon primarily what is their overall human development index as well, and what are their emissions, right? This is just to give you the global picture of it. Pretty much the same, let me just go back here. So this is annual consumption based CO2 emissions per capita. And this one is CO2 emission per capita versus GDP per capita. Just the same data, but represented differently, like whether we want to study the GDP more, or we are interested to study the consumption behavior of the state. And with respect to that, we are presenting it. And some of the countries that were, and as you can very well see in here, that some African nations, some Asian nations are sitting very low in terms of their per capita emission, which is interesting to see here, because at one point of time, I also told you that in terms of primary energy demand or usage, India is world number 3, right? But if you look at it in terms of emissions per capita, it also, because it holds a huge amount of population, it sits very low. Similarly, China, they were world number 1. And if you remember, I told you that they are an order of magnitude higher in terms of their primary energy demands or requirements, and of course, expenditure as well, the reality of primary energy in China. But still, it is sitting very low to US, though US was number 2 in terms of the ranking. But since we're talking per capita, and since India and China support and holds a huge amount of population, their per capita emission actually reduces. So they have the benefit here in terms of when we do the calculation in terms of per capita, right? So you can see here, the message here is that when we when we design solution to mitigate climate change, the idea is, and that's what I discussed yesterday as well, that the onus of cleaning the climate should not lie on these evolving economies. As such, their GDPs are low. And if they are on the path here, on this pathway to increase their GDP, to improve their economies, the major emitters should actually help them, because this crisis is a global crisis. This climate change crisis is for everyone, right? So this is the kind of discussion that ideally should have happened in all the COP. The commitments are made. If you look at COP21, the commitment was made for a certain amount of financial commitments would be made available to these developing economies. But in reality, what was the amount that was made available? Because that actually translates into action. Otherwise, as as it is said, it's all nothing but blah blah blah, right? So that is the whole thing. That was all about emissions, and because everybody's talking about emission, this course is also about carbon neutrality and emission. But let's look at the reality. I mean, if we hold the emission for a moment and see what kind of energy access is available globally. What is an access? Access means that the energy, if we talk about energy access, it should be available if you are putting the boundary to your own country, then to each of its citizens. But if we are putting the boundary to the entire globe, then it is a natural resource and it should be readily available to each and every country at a reasonable price. There should be affordability, there should be accessibility, there should be availability, and it should not be very susceptible to price change. What happened if I talk about India at the moment, the oil prices are very high at the moment. A month back, this was not the case. So the price volatility also impacts the energy access. And when energy prices soar, every other service and commodity price also goes up. So in totality, if energy is not normalized, if the price of the energy is not controlled, I and you and people in general suffer, right? And it is more so when the economies are developing, right? So energy access is very important. And of the energy access, primarily, if you look at it, the very fundamental requirement of energy is for cooking. We all need energy to cook our meals. And if you look at it, Peter Drucker, who was one of the most famous management guru, once said that what is measurable is manageable. And as you can see here, for many of the continents, there is no data. So majority of the countries here in African continent, there is no data available. We really don't know. On a global platform, maybe the data is available to the internal agencies, maybe not, I don't know. But to talk about it at a global forum, we don't have the data available with us. There's very little data available from some of the countries, and that has been compiled, and we draw correlation based on, as I told you, that as you become more and more developed, your energy demands goes up. So considering those assumptions, some calculations are made, but how close we are, how precise they are, how reliable they are, we don't know. Right? So it's important to have a global data on it. But in absence of any data, still, whatever data is available, if we use that and collate that, then this is the global scenario in terms of cooking fuel access to the clean cooking fuel. As you can see here, access to the clean fuel or technologies such as clean cook stove reduces exposure to indoor air pollution, a leading cause of death in low-income households. Okay, so if you look at, and the data also says that 40% of the world do not have access to clean fuel for cooking. Now we all need fuel to cook our meal. That is a requirement of our very survival. And which country has what kind of cooking fuel available with them in terms of access? Now, do we have a gas-based arrangement? Do we have an electrical-based arrangement? Gas-based arrangement means they're using a petroleum gas. India, for example, uses LPG, which is a liquefied petroleum gas. Or if you have an electrical arrangement, it could be induction-based, it could be microwave-based, it could be plain electrical coil-based. whatever it is, these two are considered as a clean fuel. Vis-a-vis, when we talk about solid fuel, we are primarily talking about biomass as the option. In certain countries, it could be coal as well. But we are talking about open combustion of these solid fuels. So when you burn these solid fuels, biomass, various kinds of biomass, it could be was collected from the forest floor. It could be agro residues after the harvest is done. So when we use these biomass as a fuel, how clean they combust when they are put in the cook stove? That is the question. See, any fuel, when it is combusted, when it is burned, if it is completely burned, we will get CO2. Most of them are hydrocarbons. So you understand there is hydrogen and then there is carbon. And if they are combusting clean, if there is complete combustion, then they will emit CO2 and water. All the carbon would be converted into carbon dioxide and all the hydrogen would be converted into water. If that happens, nothing could be as good as that, because biomass is also hydrocarbon. And I said LPG is considered clean, is again an hydrocarbon. It's a petroleum source, right, which is gaseous in nature. The only difference here is when we talk about gases, it is gaseous in nature, and gases burn more clean vis-a-vis solid fuel. We have all tried burning a solid fuel, a piece of paper, and we have tried gas as well. You see that when you burn gas and when you cook your meal over a gas flame, you get a very blue flame, which kind of an indicator, is a visual indicator that the combustion is happening very clean. You don't find any soot at the bottom of your vessel. It burns very clean and you don't smell anything. There is no respiratory problem, right? But when we burn something which is solid in nature, open combustion, when you hold a piece of paper and you burn it, or you take a bunch of coal when you do barbecuing, whatever way you do, you see that there are a lot of smoke coming out of it. Now, the very sign of smoke means that the combustion is not complete. You get some black smoke or gray smoke, just represent that there are some carbon particles, some black particle present, or some gray particle present in there, which itself means that the combustion is not complete. The challenge here is to make the combustion complete, which is very difficult when it is happening in an open system. You burn coal, for example, in a boiler as well, in a power plant. But then boiler gives you a lot of control. When you burn a coal in a boiler, it is so designed and it's a closed chamber where you are doing it. So the entire process is very much in your control. Now, the fundamental here is very important to understand. But the same coal or the same biomass, when you burn in a cook stove, small cook stove, household cook stove, it's very difficult. It's very difficult. I won't say impossible, but next to impossible. It's very difficult to ensure that the combustion is happening, the complete combustion is happening. That means there is no unburned amount of either the biomass or whatever secondary gases that are released there. Right? So to ensure complete combustion, because it's an open system, the moment you combust it, whatever is released, it is light in weight, it is hot, it just tries to escape. And since it's an open system, the fumes are coming out, it's very hard to hold it and to ensure that it undergoes second round of combustion so that eventually it is converted into CO2. Ideally, if there had been a complete combustion, none of us would have been talking about this cooking fuel problem. The cooking fuel problem is only because when we burn these solid fuel in cook stove, they don't burn complete. Since they don't burn complete, they create health problem. That is the first thing to whosoever is there in the kitchen. And it is released to the atmosphere and it creates another set of problems like the GHG emissions and the climate change, right? But if we could ensure, there are lots of global challenges that are thrown around, currently also open, which are talking about coming up with new design, coming up with new solutions to ensure that the solid fuels burn clean in our household systems, like the cook stove, as I talked about, right? And as you can understand that since there are lots of global challenges, that itself means that the challenge is still there. People across the world are working on it, but we haven't really come to a solution which is, which could diffuse at the level that we are looking at. I mean, if you look at the level that we are looking at, we need solutions, and almost half the world is looking for it, right? So it is there. And because of this incomplete combustion of the solid fuel, the major sufferer of it, by the very nature of the patriarchal society that we have, that cooking is considered to be the prime responsibility of the women in the house. So they suffer. And we often see that young children who are like less than 5 years and 2 years of old, they stick to their mothers, and because of which they also suffer. So the suffering is not just in terms of the GHG emission, which is impacting our climate. The suffering is also in terms of the gender. It's also in terms of the age. Right? So therefore, it is very important that the world should take it, and the world is taking it very seriously, and try to design some solution around it. If we could come up with a solution where a solid fuel could be burned more clean, it would be, and in my opinion, it would be the biggest, invention of that era, maybe that century, right? And as you can see here, there is primary risk of death and morbidity because of these indoor air pollution. Something needs to be done, and I should not say that the world is not working on it. We are doing it, but we haven't. The eureka moment hasn't yet come, because the challenge is very technical in nature. Again, that was all about pictorial form of it. And if you look at it in terms of GDP, the access to clean fuel for cooking, because in my personal opinion, I put cooking higher than electrical, because the moment we talk about energy access, in all the discussions that I have been part of, we start with cooking fuel and so on and so forth, but we all converge toward electricity, because electricity is easy to understand. You measure it, it's very measurable. You know how much amount of electricity we are feeding to the grid. There is an energy meter in every household, how much amount of energy every household is measuring. As I told you, what is measurable is manageable. Because we can measure it, it's very comfortable to talk about it. But when it comes to cooking fuel, which is the prime requirement for the very survival of us, it's difficult to talk about it, because we don't have the kind of data, a very, very clean and crisp data, which is free of noise, is not available for cooking. But whatever data is available, if you look at it, in terms of our GDP and in terms of our access, it is written here. So access is about availability, affordability, and reliability. It should be available to them. It should be reliable. It should be available. I should not live under the threat that whether tomorrow I'll be able to get this fuel or not. Right? And it should, if we talk about electricity, let's say, then I should not have the fear at the back of my mind that, I don't know, maybe tomorrow there would be a power cut. So that fear should not be there. The price should also be kind of, should not be very volatile. If I am paying, let's say, X amount to procure that fuel, tomorrow it should be available to me in X price only. Or maybe if you're plus minus, a very minuscule amount is okay, like how tolerant I am towards such kind of price shocks. But it should not be like 2x. It should not be like 3x, right? And as long as it is within 1%, 2%, or 5%, or 10% of that base value, it's okay. But it should not be beyond that. So it is about affordability. It is about reliability, and it should about availability. It should be available to every citizen as well. And as you can see here, this cooking fuel is really acute in terms of access. And as you see, I discussed about it yesterday as well. As you move toward become more and more higher, when you sit higher on the Human Development Index, your access to clean fuel is also high, as you can see here. Within certain exceptions, those who have their in-house gas production, like where the countries have their own oil and gas well, they are an exception. But in general, wherever you have to procure from international market to ensure access to clean fuel, you see that the GDP plays a very important role, like what kind of economy that country is. This is about electricity, right? And this is about electricity in 2019. And I should talk about India as well. If you look at India a couple of years back, 10 years back, this was not the case. The country was not completely electrified, but today the entire country is electrified. The access to electricity in a way is there. Almost every village, every corner of the country, as long as it is possible and feasible, is connected with the grid. the national grid. India is now a one nation, one grid. All the grid can interact with each other. When we started in 1947, when the country was freed, we had very few grid, then we had five grids, and then we started interacting. The grids were kind of started to interact with each other. They were connected, and today all the grid could interact with each other. But even with that, it was not that every corner of the country was part of the grid. But now almost the entire country is part of the grid. Where we cannot take the grid, there are certain locations which are like very small hamlet with just few household living there. It is not economically viable to take the national grid that far because you need all the infrastructure. There, decentralized arrangements are put in place. So almost the whole country is now have access to electricity, as you can see it here, vis-a-vis with any of the developed economies. And it all happened because of the policy push that the country brought in, and taking up this electrification process in a mission mode. That we have to ensure that putting up a target that by 2019, the whole country should be electrified, and lots of actions were put in place. People will be coming in and talking about this electrical movement that the country witnessed, with India as a case study, I'm sure, when we talk about the electricity market, probably the next week. Right? But in totality, if we look at world as a whole, we still have a long way to go. You can see there are about 13% of the world do not have access to electricity. Now, the problem of electricity is not as acute as the problem of cooking fuel. If you look at cooking fuel, let's just go back, it's 40% of the world do not have access to clean cooking fuel, vis-a-vis it's just 13% of the world that do not have access to electricity. And electricity is crucial for poverty alleviation and economic growth. It's very important because everything is derived from electricity. Any industry you look at it, education you look at it, we worked on, and I can talk about India as a case study. Like a couple of years back, when the country was not completely electrified, the education rates, the kind of performance that kids had at their school was not as good as when they got access to electricity. Now they have longer hours to study. Businesses bloomed. Earlier, the business was shut down as soon as the sun would set. But with ensuring that the electricity or light is available to them, they have an extended business hours, and they could generate their extra revenue, right? So electricity could trigger lots of positive benefit. Therefore, we talk about it. I mean, why electricity is important? Because it is the most convenient form of energy. Every other energy form, whatever it is not as convenient as electricity. I mean, you look at electricity, it's because of this electricity we are conducting this ITEC program, right? I mean, it is electricity which is fueling or firing your system, right? You could see it. It is because of it. I mean, if the electricity goes off, it's gone, right? So that's the power of electricity. It's very convenient. It's just a click away. It's literally a click away. You just click it on, you put the switch on, and the electricity is there to give you its service in any form. Could be the working of your computer, the light, medical appliances, water purification. Look at it, the way water is purified across the nations, right? We need electricity, the kind of services that we direct to cook your fuel. I mean, you name it, and you would see that probably you need electricity to run it. Therefore, we talk about electrical access. Again, this is to give you in terms of how access to electricity is available to the country across the GDP. And as you can see here, if you look at India here, not a very strong GDP vis-a-vis we look at some of the rest of the world. This is where it sets. We are somewhere in a modest GDP, but we still are in a position of ensuring access to electricity, or 100% access to electricity globally. And it has happened only in the last couple of years' time, right? So therefore, and given that India has a massive population and it is a fairly big country, it works as a very very motivational for other countries who are aspiring to achieve energy access. Despite our geopolitical realities, if India can do it, I'm sure other countries who are aspiring for it can also can also do it. Given the geography that we have, given the other challenges that we have, if the country could achieve 100% electricity access, then it's one of the best practice that I think the world need to learn from the country. And why energy access is important, I think I've already covered it in my previous slide, but very quickly. It is related. The life expectancy, the child mortality, the maternal rate, everything, if you look at the data and you see in terms of the number of births that are reported, the number of mortalities that are reported, and we try to link it with what kind of energy access that country has, we see that there is a direct relationship, right? There is a direct relationship, access to electricity, improved drinking water, tourists, some kind of an stimulus to your economy. Everything is related to energy and to its GDP. Very quickly, I mean, I gave that example to you here, the life expectancy. Let's zoom a bit of the life expectancy and you can see it, where we stand in terms of our GDP and in terms of our life expectancy, right? So you can see here that everything is related to access to energy. That is drinking water. As you can all see, understand that water is very important, very crucial for our health. What kind of access we have with respect to our GDP and access to electricity. Now this is, I mean, everything is not that gloomy, right? I mean, things are improving, not at the pace it should have been, but is it improving or are we are stuck? No, we are not really stuck. The good thing is we're not really stuck. You look at it, the dependency on solid fuel, that means using biomass or coal or solid fuel for cooking is actually going down. Most of the continents, you see that this bar, this line is going down. So high income countries, there is Europe and Americas. You can see here, it's very sharp. They have declines in 1980 to 2010. It has gone down. Other continents are picking up, not that steep, but it is going down. Africa, what you see here is that it's very slow. Very slow. I mean, look at the curve. If it was 80%, I mean, if it stands somewhere around, let's say 82 or 85%, then we have barely come down to 78% here, maybe. Right? Unlike other countries where probably they started, if you look at Americas, like the continents there, they started with 40% in 1980, and today they are at about 15%. So there is a huge dip from 40% to about 15 or 16% here. The good news is declining. It is declining. Across the world, it is declining. So we need some kind of a policy push here. We need some kind of an innovative design of solutions have to be designed so that the dependency of solid fuel for cooking should go down at a faster pace. That is very important. Merely saying that it is going down in Africa is not sufficient. The continent, the leaderships, the policymakers, they have to come forward and design. You cannot do it independently. You have to take, you have to collaborate with the continents who have established it, who have achieved it. Right? And probably with the countries who have similar the geopolitical and economical status as yours, you could learn better from them, right? Because the realities are similar. So if you could pick up a lesson from them, then what I see here is that it's doable and we should aspire for it. So that was all about the landscape. We talked about like how energy looks like in terms of access to energy, access to electricity, in terms of access to our cooking fuel, the businesses, the way it is done, how energy is traded, lack of it. I mean, even if you are in long-term agreement with someone and some country, and for any reason they are not able to supply that energy to you, there may be lots of terms and conditions. They talk about the spot market, and I'll show you in the coming slide that what do we mean by spot market? What are the long-term contracts? How countries do business with other countries in terms of securing their energy resources. But if at all, for any reason, for any natural reason as well, I'm not talking about the political motivation, but even if there's a natural reason for which a country is not able to supply the gas or the coal that it agreed to B country, and there was a legal document, terms and condition that we all agreed to, you may sue them, take them to court or whatever it is. But the reality is that at that particular time, at that particular moment, you are vulnerable. The country B is vulnerable because that resource is not an internal resource. It's not a domestic resource. You are actually procuring it from someone, right? And if it happens, let's say if we talk about Europe, and if that happens in the middle of the winter, right, when you know the temperatures are very down, then and all of a sudden the gas supply is stopped and you don't have a storage for it. You have not stored for a day or two because there's a gas which is continuously coming in the pipeline. I don't see a reason why it will not come. I have a long-term contract with a country, and for any reason it is stopped, then the citizens here or the businesses there are very vulnerable. So that is about energy security, right? Even if you have procured it, the block procurement in the last video that we saw is done, it's in place, but for any reason, if it is not available, what is the plan B? We need to have our plan B, C, and D ready, because if that is stopped for any reason, then all our services come to an halt. The service could be business, services, everything, your household activity, and we become very vulnerable. Therefore, energy security is very important, and every country is ensuring to be energy secure, at least to meet their certain critical demands. Even if you say that, okay, fine, I'm okay not running my other lifestyle activities like TV and all those stuff, but you do need it to cook your meal. You need it to maintain the temperatures, your indoor thermal comfort if you're living in really cold climates. So these are basic requirements for our survival. So let's call that as the critical load. So even to meet that critical load, you need to be ready with some backup, some storage with you, right? So that was all about the importance of energy, the businesses, the realities of energy, and how it moves forward. And as we saw, that majority of the world is deriving, the first few slides, that oil, gas, and coal, these three things. Now, if you look at COP26, India said that we will phase down our coal usage, right? So it's not phase out, we said we will phase down, which is, in a way, I think is true also. Your dependence on coal cannot be brought down immediately. You will slowly, you design that, okay, well, next 10 years time, this is what I'm going to do. Next 15 years time, this is what I'll do. And slowly, I'll phase it out. But it's not that tomorrow it's all done and let's get renewable. No. So every country has its own reality. You have to wait, and then you make commitments at COP or otherwise also, I mean, for your own, at the end of the day, it's the only planet that we have, and we have to take care of it. Now let's look at the trade of coal. How coal is traded. Now the coal which is mined, major suppliers, as you can see here, is in Indonesia and Australia. The coal which is present in Australia is supplied to these countries. It goes to Japan, it goes to China, it comes to, I don't know which country, okay, in some Southeastern country here, right? Similarly, they receive it from Russia. Major supplier, India, for example, receives a good amount of their coal from Indonesia. Right? We buy it from Indonesia. We also get some from North America. So this is how the businesses are done. South Africa, the coal that they mine, a part of it goes there. And you can see here the coal which is mined here in South America, in Colombia to be precise, travels all the way to Europe. So these kind of an agreement. So this country, whichever it is an agreement with this particular country, and they supply it to them. So they are vulnerable to whatever is happening in their country. Even if they have the willingness, what is the stability of the country? What is the geopolitics? What is the political stability of the region? So energy security is a very complex phenomenon. As you can see, everybody is buying from everybody else. It's very complex. It's very complex. I mean, whatever is their political relationship, their business relationships are entirely different. Right? And look at the complicated web of this coal business. So the major coal suppliers is Russia, Indonesia, Australia, South Africa, and Colombia, and United States as well. So they are the one who actually have a very upper hand when it comes to coal. And these are the major coal exporting company. We have at number one, we have Australia, Indonesia, Russia, Colombia. As you can see here, these are the countries who are exporting coal to other countries. Yes, and as you can see here, Indonesia is the second largest coal exporter, and it exports total worth of coal that they export. I mean, it's a major part of their economic generation in their country, right? And the main market of this Indonesian coal is India, China, and Japan. They supply primarily to these three countries. Major importing countries, those who import a good amount of coal, it's China is at #1, followed by India, and then there is China. So on and so forth. This is on 2016 report, as you can see here. So there is one which is importing, and then there is, so these are the one who are importing it. Sorry, these are the one who are exporting it, and these are the one who are importing it, both in terms of top 10 countries. Right? So that is how coal works. And coal basically means coal is not just for electricity purposes. There are other allied industries as well who take coal. For example, steel industry, iron and steel industry, they also need coal, different grade of coal, but they also need coal. Similarly, cement industry, they need huge amount of coal to meet their energy demand. Right. So these are the places where coal is used other than the power plants. Look at United Kingdom very quickly. This is the fuel. You know, it was discovered earlier, but the mining of it, which actually fueled the entire industrial revolution, if you look at it, right? So 1958, if just tracking it, the 20th century itself, middle of it. So initially they had sufficient coal to meet their meet their demand, sorry, till 2000. But after 2000, their demands, and they were importing a bit of it, they were coal import. But after that, their demands, import went up and their production went down. Earlier, they were producing sufficient, they didn't require to import coal, but slowly, as you can see here, they have now, in a way, maybe they're not interested to mine their coal, or maybe it's not economically viable. That we have to check. But the bottom line here is that the country, which, you know, the industrial revolution that happened because of this coal and the steam engine, is actually now importing coal. So this is a very complex nature of energy business globally. Also, and why I was talking about India all the time, if you look at the largest coal producing countries, the largest coal producing countries are also China and India, followed by US. So we produce a huge amount of coal, and we also import a huge amount of coal. So that is the reality in terms of our energy demand. Right? So we produce huge amount of coal. We have a good amount of coal reserve also that gives it a huge amount of energy security. We are not dependent, I assume, on others to meet our electrical demand. But as you can see here, we are also importing a huge amount from Indonesia to meet our demands. Right? So it's very complex. It's very complex phenomenon. Anything which is underground is which is under the ground, and then all of the fossil is mined. It's underground. It's a very complex phenomena. It's a very complex procedure to mine it. Yeah. So that was very briefly about coal. You saw the root of coal and the business of coal, the import and export, and how countries do business with each other. The next one, even more interesting, is the business of natural gas. So that was about coal, and this is another fossil fuel, which is the gas, methane, as we popularly known as. So these, as you can see here, the red dots are the export location and the yellow diamonds are the import location. So look at the web that is there, who is exporting and who is importing and how the trade is done. It is all 2010 global LNG, basically means the liquefied nitrogen gas trade route. Very important. And interesting to tell you here is that natural gas, when it is imported, it is imported in this liquefied form, as you can see here. Right? And the process of liquefaction itself is a very energy intensive process. Right? So you liquefy it so that, you know, if you could recall, even in the video that I showed you, the first video that I showed you, they showed big ships, big ships with spherical vessels on top of it. And in those spherical vessels, they were carrying liquefied nitrogen gas. So these vessels are actually cryogenic vessels. They maintain very low temperatures. They maintain very low temperature so that this gas could be, this gas could be liquefied. And we all understand that when you liquefy gas, volume reduces. So that in the same vessel, you could now pump in or store more of that gas, because anyway it will be traveled through the sea routes and those big vessels to these locations, right? So Nigeria, as you can see here, is an export point. There's a huge amount of fossil oil and gas reserve in Nigeria, and these are the country where they are supplying to, right? So you can see, you can follow the track where they are supplying it to, right? So the blue line, as you can see, it goes to US as well, and some of the other continents, as you can see here, in Mexico, so on and so forth, right? And if you look at it, we will be talking about the embodied energy, like how much of energy gas has consumed in itself while in its own process of exploration here, taking it out from the well, liquefying it, and transporting it all the way to these locations. So the trade here is, it's the gas which is extracted from the well, then it is liquefied. Let's say we are talking about a well here in Nigeria. So when it is extracted here, it is in the form of a gas, right? Then we put it in a vessel, those big cryogenic vessel, where it is liquefied, very low temperatures, minus 120 or 160, something like that, has to be maintained under atmospheric conditions. And the gas is liquefied, put in those big spherical vessels, and it traveled through those sea routes to wherever it has to go. And here again, there is a pipe network that goes through the country. It is regasified, it is converted into gas because it's easy to pump gas. So you again regasify it. So gasification, liquefaction, gasification. So from this pipe, from this well, or this pipe, from where it is extracted, we call it the well, from this well to the regasification here, because this is where it will be put to the real use. The real use could be in terms of electricity production. In India, if I talk about it, one of the alternative use of this natural gas is in our fertilizer industry. We take out hydrogen from here because natural gas is CH4. H4 is like 4 atoms of hydrogen. So we take out, you break it into hydrogen atom, and this hydrogen is used to make fertilizer. This is an alternative use, non-energy use of methane. Many country does that, right? So what is the product that we are looking at? If the product is, let's say, electricity, right? So you bring in the gas and you burn it in a gas turbine to generate electricity. So and if natural gas has X amount of energy, so the amount of energy it has lost, in this transportation, this liquefaction process itself, because maintaining that cryogenic temperature takes huge amount of energy. So you would see that all those study how it is calculated, we will be doing in the coming class, in the coming lectures, but that is important. That is the embodied energy. In its whole process, how much of energy it has consumed, it has embodied, the product has embodied is important, right? And we will be studying a bit of it today as well. So that is important. So when we talk about such long distance travels, I mean, look at it here. Here in Australia, they have an export location and they are supplying it to Japan. And how far they are here in Indonesia, they're going to US all the way here. Here in Norway, which is an export location, it is coming to Canada. It is coming from Canada. It is coming to other locations. It's a very complex web of oil and gas, and that is the reason. See, and it's very cheap when you go for long-term contracts. Your whole economy is fueled by these energy sources. Therefore, when we say that you bring it down, cut it up, you do the price analysis, and you see that you have, forget about 0 degree of freedom, you have negative degree of freedom. Like, if you do anything, it will actually bring in a negative impact on your economy. So there are countries who are willing to do, but if you look at the way the whole energy landscape is, in a way, it appears that we are very stuck. Okay, so that is about the gas thing. Again, a little, the Shankly diagram that we discussed yesterday, how it is coming from various locations and how it is distributed among various countries. Now look at the Middle East, look at how thick arrow it is. It is controlling the whole of the world. The whole of the natural gas business is very much controlled by them. What part they support to which country? I mean, Southeast Asia, like whole of the Australia, whatever it goes, 21% of this thing, it goes into the Southeast Asian market. That was about the LNG terminal in 2004 data. It's coming from the source here is the BP. So that was about gas. And if we quickly look at our crude oil business. So this is the major transport route for crude oil. Again, a huge chunk, as you can see here, coming from the Middle East, and how it goes to different countries. Who are the major producers here? So this is the OPEC Latin America. So this is the Latin American, primarily Venezuela that we're talking about. The whole economy is controlled by oil and gas, right? And you could see that how vulnerable they are. Lots of politics around energy happens in every continent. So here it is. But anyway, their economy, a major part of their economy is supported by this oil and gas business, and their major market is North America, and this one, as you can see here, it goes to Russia, this side of the world. This is OPEC Austria. I'm sorry, OPEC Africa. It's the African continent, and they also do fairly good business with other part of the world, right? They support European market, they support Asian market. A bit of their oil goes to South America as well, and of course they have their own internal consumption. Internal basically doesn't mean we're not showing the in-house consumption. It is there is an international boundary that is there, right, from one country to other, even if it is a landlocked locations, right? And if you look at this OPEC Middle East, so OPEC Middle East has a major share, as you can see with the thickness of these arrows. So here we have Iraq, Saudi Arabia, Kuwait, Qatar, Iran, and UAE. And they control, they have business with the country. A good chunk goes to Japan, as you can see in here. They support Europe, and they also import to North America. So they export it to North America. And part of it goes to South America as well. And what you see here is OPEC Asia. So we have Indonesia here. We have Myanmar and other countries are also there, where they are producing oil and gas, and they supply to other countries. So this arrow, I could see here that it is coming to Canada. Okay. As you can see here, OPEC Africa send most of its goods to Europe and Asia. Latin America produce products predominantly stay on the Western Hemisphere. So they go to the Western Hemisphere. As you can see here, it's a pretty good tool for seeing who benefited from the lower oil price, those regions that import oil from OPEC. So if you are importing your oil, OPEC is like the Organization of Petroleum Exporting Countries, if I'm not wrong, that's what it stands for. You may check. And they, it's a very strong lobby, right? They pretty much control the whole energy scenario. They are, and as you can see here, because all the major economies are actually buying oil from them, and they decide what is the price of oil at which they will be selling, and they generally, predominantly, they keep their oil prices low. So if the oil prices are low, that basically means that everybody who is buying oil from them will be benefited vis-a-vis those who are buying it at a higher price. It's just very simple mathematics, right? So OPEC countries and most of their blocks, most of their oil, whatever they have, they are in long-term contract with their clients, whichever country is their client. And we will be talking about these contracts in a moment from now. So again, the same thing. As you can see, this is part of OPEC, Saudi Arabia, how they control the business here, and how this whole the export trend or the import trend, whichever way you want to read it. 4 more exporting countries, as you can see here, represented by various arrows here: Western Africa, Saudi Arabia, right? And Central America as well. I mean, they also kind of the Central and the South America, from where the oil that goes to various countries with whom they do business. And if you look at it, I mean, we do talk about all the climate change and climate mitigation thing, but the previous couple of pictures must have shown you that how vulnerable our economies are to oil and gas and coal, because we have made ourselves dependent on them. Everything is fueled by electricity, and all the countries are producing this electricity primarily from either oil, gas, and coal. And this is the oil production since 1998. There has been a study, kind of an increase in terms of our overall oil production. This one talks about oil production and consumption. So how much they produce and how much they consumed. So let's look at Canada for the moment. So if you look at Canada, the black circle is bigger than the green circle, which basically means that they produced more and consumed less. This is what it means. It also means that whatever is the extra, they actually sold it, exported it to someone. America, if you look at it, their black circle is smaller and their green circle is bigger, or the teal, whatever color you say it. This basically means that they produced less and they consumed more, which in totality means that they exported more. Russia, on the other hand, if you look at it, they produced more, consumed less. That means they are a net exporter, net exporter, net exporter. Brazil, they are meeting their own demand, they are not dependent. So it's a very energy secure country. Then there are other countries, as you can see it here. Middle East, as you can see here, they're all producing huge amount of oil, consuming less. They are basically into the major exporter of oil. China, again, as you can see, they are producing, but their demands are higher. They are consuming much more than what they are producing. So they are basically buying from other countries. Australia as well, they are producing less and they are consuming more. India, very little reserve of oil and gas. The country is primarily dependent on export, very heavily dependent on export to meet its energy demand. As you can see, we are producing very less, we are consuming a lot. And all our demand are actually met through import. These are some of the oil and gas route, as you can see here. All pipelines, major pipelines, as you can see, coming from Kazakhstan from 2006, all set to increase significantly when expansion of the pipeline is come to 2006 when they said. So it is coming from Russia, land to land pipeline, as you can see here, coming from Russia, going to China, coming from Kazakhstan, going to China, coming from Turkmenistan, going to China. So all major route are coming from these oil exporting countries to other continents, right? So the continents, as you can see here, China is very aggressively following its, trying to meet its energy demand through these pipelines, right? And these are the major pipelines that are used. And the other ones, as you can see here, are the shipping routes. So through shipping routes, how we, so a lot of business happen in the South China Sea. This is the South China Sea, as you can see here, and a lot of business, majority of these ships that that travel between the hemisphere and the continents, they take their route through the South China Sea. Some other terminals, as you can see here, this is the landfall where it falls. Then there is territorial water border, how it goes from the waterways into the water paths, and from one country to the other country. Now, very briefly, I explained that to you. What is coal, oil, and gas, the routes, how it is transported, how it is traded. Then the third one, which is the fourth one over here, is the nuclear energy. How nuclear energy is, the landscape of the nuclear energy. So this is some of the nuclear installations, primarily for peaceful purposes. Peaceful purposes basically means in terms of electricity production. And top 10 nuclear power countries, as you can see here, are France, Slovakia, Hungary, Ukraine, Belgium, so on and so forth, right? So a huge amount, about almost 80% of its energy demand that France has is met through nuclear. Okay. However, and look at it, I mean, many of the European countries, and Finland probably is the least, but even there it's about 34% of demand is met through nuclear. Switzerland and Germany, however, has made a commitment that they would phase out their nuclear power plant and the fossil as well, but they will start with the nuclear and they will move to renewables. So majority of these power plant, as you see, is available here. These are, and the whole world is going in a big way toward nuclear. We are talking about renewable and all those things, but there are a lot of things that are happening for nuclear as well. So world as a general, this red dot indicates the current operational nuclear power plants. And this bigger one, this actually shows the planned one. So we are almost doubling our capacities in terms of nuclear installation that we have. So every country, look at India, 17 to 61, that's their plan. China, 11 to 140, Japan, South Korea, US, Canada, look at it. So big thing happening in nuclear as well. And we will be discussing the emissions that are coming from nuclear maybe tomorrow or the following class. But nuclear is clean in terms of their emissions, in terms of their operations, right? Otherwise, nuclear is a very complex system. Yes, it certainly is clean because there is no emission, there is no CO2, the emissions when it is operating. But the entire life of a nuclear reactor, if we study that, then the question remains, is nuclear clean? Is nuclear safe? All these questions and the complexities of nuclear will be discussed later in the training program. But the point that I'm trying to make here is we are going in a big way toward nuclear. The business of nuclear, how the nuclear fuel is procured. So there is a nuclear suppliers group, we call it the NSG. It's a multilateral, that means multiple organizations, multiple countries are there. Export control regime and a group of nuclear supplier countries that seek to prevent nuclear proliferation by controlling the export of material, equipment, and technology that can be used to manufacture nuclear weapons. So basically, NSG looks after the business of nuclear, not just in terms of raw material, that means the nuclear fuel, uranium, and others, but also the technology. Who is selling technology to whom and for what? This group actually was formed to ensure that nuclear is used for peaceful application only. There's a very interesting history behind the formation of NSG, but if I have to sum it up in one single line, it clearly says that NSG was founded in response to the Indian nuclear test in May 1974. And it was immediately formed, and the first time it came together and met and came up with their guidelines and chalk out their working procedure was in November 1975. Right? So NSG was primarily formed after India tested its demonstrated its nuclear facility, nuclear knowledge. NSG today, when it started in 1974, there were only 7 participating countries like Canada, Germany at that time was Western Germany, France, Japan, Soviet Union, and United Kingdom, and of course, United States. But later on, different countries joined, and as of 2020, there are 48 participating governments. So there are 48 countries who are part of this nuclear suppliers group. So they are the one who are involved in the procurement or the selling of the nuclear fuel, which is the nuclear fuel, the very fuel that you need, as well as the technologies that are required for nuclear peaceful activity. Very briefly, I think we have almost come to an end of our class today, is a contract. So in the first video that I showed you, we read about the spot markets and buying the entire block, how it is done. So spot contracts are basically a single shipment. So you just, for one-time order, you do it. Because there is a crisis, you immediately try to fill it up. It's like an emergency purchase. Nobody wants to buy it from spot contracts because they are expensive. It's just like you are in need and therefore something should be done. It's like an emergency thing. So that is spot market. And because of an unforeseen, something that you could not envisage, all of a sudden there is a surge in demand. So you try to meet it through spot contract. Normally they are into term contracts wherein big contracts are made over a long period of time at a certain price, and you try to both in try to negotiate the one which will be importing it, because they try to keep the price in control. The one who are exporting it, they are also in terms of, there will be people who will be coming and talking about this contract in detail later. There are people, countries who are actually exporting it, would try to put it at a higher price, would try to, they don't really want to get into long-term contracts, because they see that if for any reason, if the price of the fuel goes up, it is sold at 5, whatever currency you can think of, 5, and internationally the spot market price is, let's say, 10, and the regular price, people who are entering into new contracts are buying it at 5, and you agreed to sell it at 2 to them, to the country where you are importing, then you are a net loser in terms of 3 units. So they try to avoid it, but the one who are importing, they try to enter into it. So there are a lot of negotiations that happen. There are a lot of terms and conditions that are put in place. But the bottom line is that most of the resources that are available, known to us, are very much already in long-term contracts with their clients. So today, if you say that let's go and buy a big amount of coal from someone, we enter into a long-term contract with somebody, until unless a new block of coal is discovered or a new oil and gas fields are discovered where they are looking for clients, most of the established businesses, which are like mature businesses, are already in long-term contract with their clients, right? So yes, so most of the resources are very much in contract with the already contracted, right? And to talk about the geopolitics of the energy, with this I'll end my presentation. Let me just give you one quick, hear it about the politics of energy from a very eminent speaker who is, just hold on. Just hold on for a second.
Agency is always disclosing well.
Is it audible, Imli?
Thank you. Thank you.
Is it audible?
Yes, ma'am, we can hear.
Okay, thank you.
Ladies and gentlemen, it's a great honor for me to have a presentation about energy geopolitics. IEA, World International Energy Agency, is always disclosing World Energy Outlook every year. 2 years ago, it mentioned about 4 revolutions in the energy market. First is the shale revolution in the United States. The United States is now the largest producer of oil and probably will gas. And this is a really dominant status. So US is now enjoying energy dominance of the world. Mr. Trump's policy of this fossil fuel is magnificent. Second revolution, solar photovoltaic revolution. IEA said solar photovoltaic will be the cheapest source of new electricity in the near years. And this is really surprising for me. Solar has been very expensive energy before, but future will be very different. What will happen to coal? What will happen to gas? What will happen to nuclear energy if that is the case? Third revolution is China. Green China. China's green revolution changed the world by using more gas and renewable energy. The fourth is electrification. Energy is served through electricity, not burning, but digitalization, electric vehicle, AI, big data. This is the fourth revolution. Look, out of these 4 revolutions, 3 of them, the latter 3 of them are happening in China or led by China. While US is still conventional leader, China is changing the world by 3 revolutions in the renewables. But China is not doing it for sustainability. This is the geopolitical strategy of China. Because by using more renewables, China can reduce dependency of oil from Middle East, very unstable Middle East, or from Russia by gas, or from gas and oil from United States. This is the energy independence policy of China. US is using fossil fuel, gas and oil. China is using renewables. Who will win in this game? China is the largest user of energy. US is the second largest. This is the big change in the energy market, and everybody must be aware and impacted by this contrast. This is the oil producers' game. US, the green is US, is taking advantage of high oil price, the red is oil price, and increasing the production by 6 million barrels per day, half of the Saudi's capacity. Saudi Arabia is blue, and yellow is Russia. And now, US is the largest producer. And to face with shale challenge, Russia and Saudi Arabia made a coalition by reducing production and pushing the price up. But that benefit always goes to the US. This is a big fight between US and Russia, Saudi Arabia. Where the Middle East oil goes. In the future, China, India, Japan, Korea are the importer of oil from Middle East. 90% of oil will go to Asia. Look, the United States will no longer need oil from the Middle East. Will US continue to defend the Persian Gulf free navigation of the Strait of Hormuz? This is a role for China, India, Korea, Japan, and Asian countries. Japan and China is fighting in the East China Sea or South China Sea, but we have to work closely together in the Persian Gulf.
We have this entire misunderstanding of what Darwin really meant when he said survival of the fittest.
This is the Persian Gulf, Hormuz Strait. If this closure happens closure happens in the Persian Gulf, we are going to lose 60 million barrels per day of supply. Huge problem for Asia. I am proposing to face this kind of shortage, China should join IEA, International Energy Agency, together with India. It is only limited to the OECD, but it is China's necessity to defend energy security of supply disruption of oil, together with India. India applied officially to be the member. It is China who should follow and come together the IEA. This is a really big change because United States is no longer need IEA. They are energy independent. The beneficiary of IEA is China and India. And also China is going to be the largest importer of LNG gas. United States is the largest exporter of the gas in the future. Two major players of the gas are fighting in the trade war. This will certainly impact the gas market. China is trying to use one belt, one road of pipeline and diversity of the sources of gas. But this protection of the sea lane shows the concern, raise the concern of the United States. This map I copied from American Defense Department's China report. Every year it's getting more and more details and very interesting. Energy issue is geopolitical and national security or military-related issue. This map is, this chart is depicting countries by gas or import dependency in the vertical line. In the horizontal line is oil import dependency. China needs now import about 60% of oil and 40% of gas, but eventually 80% of gas and 50% of gas should come from importation. India is much worse situation. Japan, Korea importing 100% of oil and gas. It cannot be worse. United States moved different direction. They are exporting already gas and exporting oil very soon. So US position is much closer to Russia and Middle East in a geopolitical advantage. China and India should work closely with IEA countries like Japan, Korea, and Europe to defend its energy security by joining. India is much worse situation, so India applied first, but it's now that China's turn. Cost of solar and batteries going so low. So China's strategy is, another strategy is connecting grid lines around the country and together with neighboring countries. This big global energy interconnection is Belt and Road Initiative of electricity grid. Very strategic geopolitical move of China. Asia super grid, this is a Japanese idea. Masayoshi Son, the chairman of the SoftBank, is selling this idea by connecting. This is another interesting collective energy security and sustainability for Asia. Japan and China should work closely with making this kind of scenario in the future. Nuclear issue is very interesting. This photograph is from the L'Aquila summit in G8 in 2009. I was invited as an energy expert, and this is the first summit for President Obama. He patted on me, and you are the energy guy. I know energy issues very well. In the lunch, there are a good number of African leaders together. And the guy who was sitting next to me was Gaddafi. And he talked about colonialism is an issue. And then came Obama. I know Africa very well. It's the corruption is the issue he raised. And corruption has nothing to do with the colonialism. Total silence happened. Merkel said, yeah, corruption. The discussion changed from colonialism to corruption. But Gaddafi was killed by the invasion of United Nations Army and US, and that sent a terrible message to North Korea, because Gaddafi said, I gave up nuclear weapon myself, and I also tried to convince North Korea to do the same, but he didn't make it, and his mistake should never be repeated in Kim Jong-un's mind. So, energy issue, but nuclear is very much issue of security. Well, ladies and gentlemen, Japan should work more together with China to the non-proliferation regime, peaceful use of nuclear. This is the only way to get the trust Japan lost after the Fukushima accident about the nuclear power. We have to buy the plutonium from North Korea, and this helps, together with China, the nuclearization of the Korean Peninsula. I wish the nuclear issue is not only the economy or energy, but very important national security and geopolitical issue. Thank you very much for your attention.
Yes, so thank you, everyone. We are done with this course. That was a brief idea about how the geopolitics of energy, and I don't think any other time would have been a better time to discuss it than immediately after the COP26. So thank you. This session is over. We break for about 20 minutes now, and the next speaker will join at 11:30. About 20 minutes from now, we can break, and we will reassemble at 11:30 India times, 20 minutes from now. Thank you, everyone. Thank you very much.